All right, so we're downloading product list.xlsm, and I'm going to open it up. So today, then, we're talking really about kind of two topics that are closely related to each other. One is debugging, and the other one is error handling. There's a question. I think I started recording. Yeah, thanks for checking. I appreciate it. So, so debugging and error trapping. So let's kind of first talk about the three different kinds of bugs that there are. There are three kind of categories of bugs. The first bug is what we call a syntax error. And a syntax error, the bug is so bad that when the interpreter looks at what you're trying to do, it just can't figure it out. It's looking at it, and it says, you're saying something, but it doesn't make any sense at all. Or maybe the individual parts of it make sense, but the way you put them together, I don't know what to do with it. And in that case, the interpreter just kind of throws up its hand and says, I just can't work with this. You know, get your act together, and then we'll talk with what it's saying. And so I think I've even given you a syntax error in the sub-procedure that we have here. So I'm going to go ahead and open up my Visual Basic Editor. Yeah. So here we have a syntax error. Nice thing about syntax error is that most often they show in red. And in fact, how many of you, when you make a syntax error, you're still getting the dialog box that pops up and says, there was an error? Any of you still getting that? Or I know I showed you. Let's show again how to get rid of that, because that's really annoying. So I'm going to choose Tools, Options, and then the very first checkbox here is Auto Syntax Check. The truth is, it's going to automatically check your syntax regardless of whether this is checked or not. But if this box is checked, it will display that message box whenever you have a syntax error. You uncheck it, it'll still show in red, but you won't get the message box. And the whole idea of that message box is there's a button that they have mislabeled help. What should they have called that button instead of help? They should have called it no help, because that's what it is. It's no help. But you know, if you wanted to kill some time while you wait for the web browser to load and bring up the page, you can. So we look at this line, and there is something about this line that the interpreter looks at and goes, yeah, I have no idea what you're talking about. Do you see it? Yeah, what is it? Yeah, until is spelled wrong. And the truth is, I spell until wrong almost, well, maybe as many as half the times I type it. U-N-T, so it should be T-I-L, not I-T-L, T-I-L. And so I'll change that and leave the line, and it stays black. It goes, oh, yeah, okay, I understand what you're talking about now. So it's tempting to think, every syntax error shows in red. That's not the case. Some syntax errors don't show in red. I'm going to make a syntax error here. I'm going to get rid of the word loop. Is this code syntactically valid? No, I got to do, that's a little promise to have a loop somewhere, and there's no loop. But no line is red. Why not? Yeah, there's no line. This line is beautiful. It's perfect. But the line that kind of needs to exist to complete it isn't there, and so there's nothing to make red. So we can have syntax errors that are show up in our code, and then others that don't. And when they don't, it's that we're missing something. Okay, so that's the idea of a syntax error. You got no option with syntax errors than just to get rid of them. The good news is they're easy to find, right? Because the interpreter, or I should say the code editor, will show you right where those syntax errors are. I remember when I very first started programming, the language was a version of BASIC called C BASIC. It was on the CP/M operating system, and it was a compilable BASIC. It was really kind of a neat language. But you didn't get any clue that you had a syntax error until you said, hey, I want to compile this program. So there's a separate program you would run on your file, and it would go and compile it. And then if you had one little error somewhere, it might give you 20 or 30 different lines of errors, because it was like there would be an error that comes as a result of that code not being in place, and it was just really hideous to work with. So having an editor that will show you where the syntax errors is really great. Okay, so that's the first time, syntax error. Let me talk about kind of the third category of error, which is called a logic error. A logic error is, as far as the computer is concerned, no error at all. It has understood everything that you have told it to do, and when it runs it, it does it just fine. A logic error is when you have inadvertently told the computer to do something other than what you thought you told it to do. And so this error happens where? It's in your head, right? You're not understanding what you told it to do. And there's no help. The interpreter is not going to help you with this one, because as far as it's concerned, it's doing everything just fine. And so logic errors take some effort to track down, and that's really what the whole suite of debugging tools have been designed to help us track down logic errors. We can find syntax errors, no problem, but we have all these tools to help us find the logic errors. And actually, let's talk about this line here, which I don't think we've talked about, except maybe in passing. So how many of you, when you create a new module, option explicit doesn't show up at the top? So there's several of you here. Let's change that for you. You definitely want option explicit to be shown here. Your code will work just fine without it, but it's a little harder to debug, and let me show you why. So first, let's choose Tools, Options, and it's the second one. So auto syntax check was the first one. Require variable declaration is off by default. We can go ahead and check that one to turn it on. And what that does is it says, hey, from now on, when you make a new module, let's just put the word option explicit at the top. So what does this mean? Option means this is an option for the interpreter. You're telling the interpreter how to behave. It's not a line that it looks at and goes, oh, I'm going to do something in your program because of this. No, no, no. It says, as I go through to compile this or to work with this code, I'm going to behave differently because this option was in place. And so this option says, it says require that variables be explicitly declared. So let's just do this. So I've declared my row variable here, and this is a pretty simple loop, just loops across the data that we have here in the product sheet. But I'm going to take off option explicit, maybe just by turning it into a comment. And then I'm going to put a logic error into my code. I'm going to take the W off of row here, or maybe I'll do it like this. That looks kind of like row, a couple of V's, kind of wide W, but. So now, without option explicit, and remember here that in VBA, if you don't declare your variables, the interpreter will declare them for you. So let's just kind of look at what happens here. The interpreter is going along and it goes sub, great, I got it, dim, row as long, beautiful, know what you're talking about. We're giving a value here, making up a loop. We're printing some stuff out. Goes, you row, I know that, it's a variable you declared up here. That's great. We're giving it a new value, equal sign, and it gets to this. And it goes ROVV. And it goes ROVV. That doesn't even sound remotely familiar. And it looks through all the things it could possibly know. It looks through all of the statements, like it says, it looks through the list, and there's like sub, and there's function, and there's dim, and there's like the do and the for loop. It's looking through all of its reserved words. And it goes, nope, 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 no, it's not one of those. And then it looks through all the objects that it could possibly be here in VBA and Excel. And it goes, there's no object named that. And it looks through everything else that it possibly knows about. And it finishes them all and it goes, it's nothing. It's nothing that I know about. And then it goes, wait a minute. This could be a variable that didn't get declared. Ah, that's the only thing it could possibly be. And so instead of stopping and saying, here's a variable you didn't declare, it says, oh, you forgot to declare this variable. I got you covered. I'll declare it for you. And it does, allocates memory for it. It says we request some memory from the operating system. We're going to call this variable ROVV. And by the way, what's the type going to be? Yeah, it's good. You're going to need to know some types, for the exam, which is running now. So it'll be a variant type. And the good thing about variant is that I treat it like a number as I'm doing here. It'll behave like a number. So what value is it going to have as a number? It'll be 0. So I'm going to get right to here. And it's going to go, let's say row is 2. We're giving a new value to row here. And row is going to be 0 plus 1. Row is now going to be 1. And we're going to come to the loop. And then row is going to be, the next time through, row is going to be 1. Yeah, we're not ever doing anything to change ROV here. And so I've just converted this into an endless loop. That's going to run, you can kind of see it kind of flickering through here. It's just running, printing off what's on row 1, and it will do it forever. Well, not forever. Computer won't last forever, but for next to forever. So because I didn't have option explicit set, I've converted what otherwise might be a syntax error into a logic error. And it turns out a misspelled variable name is a pretty tough one to track down. And so I'll go ahead and stop this. Fortunately, because I have do events in here, I can stop that code from running. Otherwise, I'd have to kill Excel and start Excel again. But now let me go ahead and bring option explicit back. And now when I run it, the interpreter goes through that same process. It looks at ROVV and it says, what could this possibly be? And it eliminates everything else and it goes, must be a variable. And then it goes, well, wait a minute, this variable hasn't been declared. And because I said, I'm requiring myself to explicitly declare all my variables, this now becomes a syntax error and it tells me, no good, this variable is not defined. And I go, what are you talking about? RO, those aren't W's. That is two V's next to each other. Then I can fix it, and then we're off and running. Okay, so those are two of the three kinds of errors. Syntax errors, can't compile. Logic errors, compile just fine, run just fine, but don't do what we thought we wanted them to do. There's one that's kind of in between those two that is, we'll spend most of our time on today, called a runtime error. Runtime error happens not at design time, but at runtime. So in fact, here, let's go ahead and make a runtime error here. I'm going to put in here, we're going to delete something. Delete. Oh, let's see, the worksheets. We'll give it a name. Let's delete the product worksheet. So PRODUCTS.delete. Okay, so we're going to delete the products worksheet. Syntactically, what do you think? Is the syntax of this correct? The question? Oh, I'm pretty bad at that. And like this is like the only time in the whole semester that I'm going to misspell something on purpose, right? So yeah, this is going to be a problem. But is the syntax right? Have I broken any rules about VBA with this line? Right? I mean, I could break a rule about VBA instead of loop. I could call it lop. That's not right. Syntactically not valid. Or LO0. I've always wondered why the 0 and the O are right next to each other on the keyboard. Syntactically beautiful. The interpreter looks at this and it goes worksheets. I know what that is. It's a collection of worksheets. And oh, we've got parentheses here, so we're going to identify one of them. So I'm expecting one or two things in here. What am I expecting in here? Either a number telling me which number of the worksheet I'm after, or a string going to the name. Either one of those is good. I got a string here. That looks great. Dot afterwards, that's wonderful. Delete, that's the method. That looks great. The interpreter looks at that and goes, that's perfect. That's fine. But when I go to run this, it goes, yeah. This is runtime error number 9. I feel pretty good when I get a low runtime error. It's like the 9th error they thought of, and I managed to find it. You know, the most common error you'll see is 1004, which is analogous to there was an error. I mean, that's what it is. But error number 9, that's pretty good. Subscript out of range. Now, why this is called a subscript is a little bit, there's really no subscript involved here, but I'll tell you why it's here. I'll hit debug, and it tells me this is a line where the problem is. Now, by the way, if I was, let's say, a different way to refer to worksheets. Worksheet, and now, and you'll see this like in academic papers. You know, I've got worksheet, worksheet. I've got, you know, 3 different worksheets that I want to keep track of each other. So I'm going to call them all worksheet, but I'm going to give them a number to keep track of which ones I'm talking about. So this will be worksheet 1, worksheet 2, and worksheet 3, but I'm going to make that in a really small font and sunken down, drop down a little bit by the end of the word. What's that called? When I take a number, I make it smaller and I put it below the normal line where the letters sit. That's called a subscript, right? Superscript, you raise it up. Subscript, you push it down. And so I could have worksheet, and now I don't have a font here that I could actually do that. There's no font involved here in programming. So, you know, I'd like to just have that be a subscript, but I can't do it. So instead, what do? I put it in parentheses. And syntactically, we'd call that worksheets. And then in parentheses, I say number 1. Well, we call that a subscript. If only we could write it as a subscript, we would. But we can't. And so instead, we call it in parentheses, but we still call it a subscript. And so when we run this code down here, it says subscript out of range. It's really what it would get if I was like this. Instead of prod cuts, if it was like, you know, 100. Now, I only have like 2 worksheets here, so there's not a number 100 worksheet. And so now this really is right, the subscript out of range. That is exactly what this is. What's the valid range for a subscript in this workbook right now? Yeah, 1 to 2. 100 is way out of it. This error should say subscript way out of range, what it should say. But they're happy enough to say it's out of range. But the point is that this is really the same problem. I'm trying to refer to a member of a collection that doesn't exist. And so even though there's no subscript involved, we get the same error message. And this is just kind of part of the way that, you know, the folks who write, not just this language, but any language, the error messages are typically not as good as you want them to be. And not as good as they could be if they really, you know, put a little more effort into it. So that's why it's called subscript header range, but that's a runtime error. Syntactically, it's just fine. Now, could the interpreter look at that and go, you know, before I even start running this, I'm going to check and see if there is a worksheet called prod cuts, and stop me before I even start running to say, hey, this is not valid. Could it do that? Yeah, it could do that. How many of you think it should do that? You know what? It's not going to exist. They should do it. A few of us here, I kind of feel that way sometimes as well. But here's the problem. The problem is that the interpreter doesn't have any way of knowing if that sheet is going to exist by the time this code executes. It could be that there's some code in another workbook that creates the worksheet. It could be that we're anticipating the user creating a worksheet by hand and calling it prod cuts, and we're going to delete it. And so there's no hope that it could look at that and say, best it can do is say the syntax is all right. It says worksheets, we've got parentheses, there's an opening and a closing parenthesis. We've got a string in there that looks right, dot delete, that all looks great. But it can't go the next step and say, well, that doesn't exist, because it might exist by the time this has to run. And so this is a runtime error. Runtime error is syntactically looks great. It can compile. But when we go to run it, the condition that has to exist for this line to actually execute isn't met. And what's the condition that has to be met here? Well, there has to be a worksheet called prod cuts. And if it's not there, then this now is a runtime error. Nice thing about runtime errors is that the interpreter shows you exactly where they are. Well, it's not always exactly right where the error is, but it shows you the line that it got to and went, I just couldn't do this. I just don't, I can't do this. So sometimes the error is just a little bit before that, but most often it's the line that really can't execute. Okay, so questions on what a runtime error is. All right, let's go. So our choice now, our choice with logic errors and with syntax errors, we just got to get rid of them. We have two options with runtime error. Runtime errors, we can get rid of it, prevent it from happening. Or two, we could trap it. That is, when the error happens, we could pay close attention. And when the error happens, we could say, aha, it was an error. And we could say, all right, don't go crazy, interpreter. When this error happens, I'm going to give you some other things to think about and to do. So don't just stop. We'll kind of continue. Because in fact, the reason the interpreter stops is it got to this line, it tried to do it, and it went, I can't do this. I don't know what to do. And so it has no option but to stop. What we're going to say with an error trap is we're going to say, listen, if you get to a line that you can't do, hey, I'll give you something else to do. And the interpreters are great. I mean, I don't care what it is as long as I'm doing something. I'll be glad to do whatever. And so that's the idea for an error trap. So to do this, let's look at a different example. We're going to come back to process products. I'm getting rid of that delete, the delete, let's go back. I'm getting rid of this delete statement. That's just so we can kind of look at this statement. And now, here's what I'd like to do. So if I look at this data, and we're going to spend some time in this data in some upcoming examples, it would be helpful if I could have a list of my departments. There's like 800 and some odd, 860 or so products here. And there's only 4 products of like hunting, outdoor, apparel, and general. That's it. And it might be really nice to just have that set somewhere. So if you had to make that set, how would you do it? Just in Excel, what would you do? I might make a filter, and then could you copy it, filter? Yeah, that would probably work. Are there other tools that are, the other big one I'm thinking of is? Yeah, there's a remove duplicates feature right here in the data tab, right? Data, remove duplicates. Don't want to do it here because this is my raw data, but you're right, copy the column to another sheet, remove the duplicates, and that would be great. Now, if the data is not, we're not going to be adding anything to the data, that's probably the way I would do it too. But it might be that we've got people entering data into this worksheet, and when they add a new department, we want to automatically add that to the list. So I would like to be able to create a procedure here that can kind of look over this data and build that list, kind of anytime. And maybe even when I get a new value, just go ahead and try and add it to the list. So let's go ahead. I'm going to make a sub procedure called build lists. I'll call it build list. Sub build, B-U-I-L-D, list. We're going to give it some parameters here in a moment, but for right now, let's start out with nothing in it. So for my list to exist, I'm going to want to have a sheet that's going to hold the lists, and I'll call it lists, because I'll probably have a list of all my departments. Need to import data? No, but thank you for asking. I'll probably have all a list of my departments. Maybe I'll have a list of my manufacturers. Maybe I'll have a list of my categories. I don't know what else there is to make lists of. And so it's not just going to be a sheet just for my department. I'll have a sheet that keeps track of my separate lists. So great. So let's go ahead and create it. So let me just dim S as a worksheet. And let's set S equal to worksheets dot add. And then I'll say S dot name equals list, L-I-S-T-S, lists. This looks great. In fact, it looks so great, I'm going to run it and it's going to work great too. Look at that. It ran perfectly. It created a new sheet. It called it lists. I'm in great shape. Now, the trouble is, what's going to happen if I try to run this again? Yeah, this will work part way. That name, this is actually a pretty good error. That name is already taken. Try a different one. Now, trouble is, I created a new sheet. But the error happens when I try to name it to the same name as an existing sheet. So what kind of error is this? Syntax error, logic error, or runtime error? Yeah, if you ever see a yellow line with an arrow next to it, it's a runtime error, right? It means that, well, if it happens automatically, we can put ourselves into break mode without having an error. But so I tried, got to this line, I couldn't do it. I compiled it okay, but I couldn't actually execute it. So we have two options here, right? We can prevent it from happening, or we can watch for it to happen and decide what to do when it happens. And so, truth is, I'm kind of conflicted here because I think it's probably a better approach is to say, let's just check and see if the page is there, if the sheet's there, and if so, we'll bind the variable onto it instead of creating it first. But I'm trying to show you error traps. This will be a pretty good one, a pretty simple one to understand. So, by the way, what would it take to look to see if that sheet exists? Is there something already built into like the worksheets collection where I can just ask, does a sheet with this name exist? That would be great. The answer is no. There's no, this worksheet, does this worksheet exist? So we'd have to make it ourselves. You know enough, well, we've talked about enough for you to be able to do this so far. So what would it take? You want to know if a worksheet named list exists in this workbook. What would you do? Go ahead.
You'd probably count the number in the collection and do a loop through the index to show how many elements and check the equals.
Yeah, exactly right. Listen, I'm just gonna, there's several ways that I can iterate across this sheet. I can use the for each loop, which is kind of hardwired for this. I can use the for next loop, figure out how many I'm gonna do. I can even use a while loop with a little extra effort on it. But I'm just gonna look at each one and I'm gonna say, is there one called list? Nope. Is this one called list? Oh yeah, already there. Don't have to make it. We could do it that way. It seems like a lot of work. So let's look at the other way. So in this case, we're going to say just watch for the error to happen. And when the error happens, let's behave accordingly. So I'm going to stop my code. I'm going to delete the sheet that we created from this time. Yeah, delete it permanently. That's great. And now we're going to come back and we're going to set up an error trap. Now, there are two fundamentally different kinds of error traps. The book talks about both of them. I have found the one that I'm going to show you today to be by far the more useful one in programming in VBA. And this may be just my own preference, but one approach says, kind of at the top of your sub-procedure, you'll say, listen, interpreter, if there's an error, I'm going to send you somewhere else in my program to go, probably towards the bottom of this sub-procedure, to decide what to do if there's an error. And this can be really helpful if you're saying, I'm not sure where the error might happen. And so I'm about to give this worksheet over here to Edna from accounting, and who knows what she's going to figure out how to make this break. And so I might say, I'm not sure where an error might happen, but if it does, I'd like to get a text message that it happened with some information about where and why it happened. And so that's kind of one approach to say, we're going to have the error come down here, and the error happens, so the code is going to stop, but send me off an email or send me a text message so that I, as the creator, can know what's going on. I'll try to keep in touch with my creations. And so that's one approach. The second approach is a broadly defined error trap. Here, what I'm going to show you today is a narrowly defined error trap. I'm going to say, here's a line that I am anticipating could cause an error. And I may even understand why it would cause an error. And so I'm going to build a small error trap right around this line to decide what to happen when this goes bad. So here's how I set up that error trap. I am going to come here and say on error. So this statement on error is a signal to the interpreter to saying, listen, if you run into an error, don't just stop. I'll give you something to do. So I might say go to some other place. That's the other trap I was talking about. For this one, on error, resume next. Ooh, this is kind of a dangerous statement to leave by itself. What this one says to the interpreter is that from here to the rest of the sub-procedure, if you get an error, whatever that line was must not have been important anyway, ignore it and move on. This will turn all of your runtime errors into what kind of errors? Logic errors, yeah. Which one's easier to find, runtime or logic? Yeah, runtime. You'd much rather find a runtime error than a logic error. And this line just would say, runtime error, forget it, and won't show you where the problem is. Is your code going to do what you want it to do? Not a chance. It really won't. So we're going to be very narrow about how we use this. So here's what we're going to do. After the line happens that is suspect, we're going to try to look to see. In fact, let me. You can go ahead and leave that on. I'm going to go ahead and run this again. It's already taken. Let me come to debug mode. Oh, and look at this. There are two things. The error number is 1004, and then it has this message right here, this description of the error. I'm going to come up here to my immediate window, and there's an object now that has those very values in it, err.number, 1004, and err.description. Was that the same one? No, it was a different description, was it? Interesting. Method name of, I'm not quite sure how they're getting that. Is there another error? Is there another option here? err.description help context. Raise source, yeah, it's none of those. I'm not sure how they're doing that, but anyway, we have access to both a number and a description of the error. And so let me stop my code, bring back my on error, resume next, go delete the sheet that it made again. So now I can, this error with my on error, resume next, this error now, instead of stopping my code, will just put the information into the error object that I can inspect. So now after my suspect line, I will say if err.number equals 0, then we'll do something. What is error number 0? No error at all. So this is just fine. In fact, I don't really want to do anything here at all, but I'm just going to leave it here because the code is a little nicer to read this way. No error. Continue on your merry way. Else if err.number equals, what was my number? 1004. This is the error I'm anticipating, I think might happen. Then we'll do something else and if. Now, else, if I get to this point in my code right here, what does it mean? What could you say if I ever get to this part of this if structure? Go ahead. Yeah, that's right. I have, and what he said, in case you didn't hear it, was any other option besides these two that we've already looked for. So if the error number is not 0, well, that means, error number 0 means there's no error. So error number, if I don't go in here, then it means there was an error, and it's not error number 1004. So if I make it to here, there's an error that was one I wasn't anticipating. In this case, I want to know about this. So what I'm going to do is I'm just going to put here stop. Stop, as you know, we've used it quite a bit. It just says stop the code, take me into break mode right here. So if I ever get that error, I've really just kind of turned this back into a runtime error, essentially. Get to this point of the code and stop, and I'll be able to look and see, oh, there was an error. It wasn't error number 0. I could ask what it was. I could come to the immediate window and say, in fact, if I wanted to, I could put up the message box. Again, with all the information in it. But now, what am I going to do if there is an error? If there is error number 1004. So in this case, what am I going to do? I kind of have to undo. So what this means, the sheet lists already exists. So I don't need to, I don't need to rename that sheet. In fact, I didn't want to create it in the first place. I better uncreate it. Fortunately, there's a function for uncreating. So I'm just going to say s.uncreate. Oh, no, it's delete. There's no uncreate, it's delete. So that will just delete that worksheet. Now, I still want my s variable to be bound onto my list worksheet, but now I know it exists. And so I'll just say set s equal to worksheets, worksheet named lists. So by the time I get here, I will say, aha, now I know. Beyond the shadow of any doubt. Now I know that list sheet exists and S is bound to it. Right? Because if I didn't have an error, I created the sheet and I named it lists. If I did have an error, I deleted the one that I created and then I bound S onto the right one. So that's a good thing to know. Now I know the sheet exists and I've got a reference to it. So I can just use S now as another name for that sheet. But at this point, I am done dealing with that error. And so I better come right here and tell the error number, tell the error handler to go back to normal. So I say on error, go back to normal. But how do I tell it to go back to normal? This part is the strangest syntax of all of VBA. You ready? Go to 0. This means resume normal error handling. In other words, after this point, if you get to a runtime error, stop, show me the error, put up the dialog box that says runtime error number 9, subscript out of range. Would you like to know why? There's a reason why that's what it is. Do you want to hear what it is, or you want to just believe and move on? You believe? I got this half saying I believe, and then I want to hear it. I'll tell you really quickly. In the early days of BASIC, when you programmed, it's crazy, but when you programmed, you had to number every one of your lines. You would start typing off, this is line number 1. You would put a 1, you'd write your line. This is line number 2. Line 2, you'd write your line. Line number 3, write your line. What would happen if you decided you wanted to have a line between line 1 and 2? Well, you'd put a new line in there, you'd call it 2, and you'd renumber all the rest of the lines. Oh, what was 2 is now 3, and what was 3 is now 4. So that we would actually do, no, we're going to, instead of, maybe we'll go 10. This is line 10, this is line 20, this is line 30. So I have a little bit of space to work in between these lines if I need to. You can even buy programs that would renumber the lines for you on your program. You know, and because it wasn't just the lines, because you'd use those lines as references to jump to different parts of the code. It was terrible. It was really terrible. Can you guess what the very first valid line number is? It's not 0. It's 1. And so when you tell the Visual Basic Interpreter, go to line number 0, it's going, there's no line 0. And it has no option but to go back to its default error handling. You've told it to do the impossible. Visual Basic will do a lot of great things, but it won't do the impossible. And so that's kind of the origin of where that is. It's kind of bizarre that they didn't come up with another word for it. On error, I don't know what else they would call it, but maybe they tried and they couldn't think of anything better either, so I don't know. Okay, now the other thing that some people like to do is they like to say, you know what, I want to do that same thing in here just as soon as I have figured out which error number I'm on. Because if I've made myself a little error in here, if my on error resume next is still active, I won't know about it. And so what some folks do, and I'm kind of sometimes I do it one way, sometimes I do another way, is to say, all I needed to do was find out what number it is, and now I can turn that error handler back off. By the way, when you say on error go to 0, it sets the error, it resets the error object. So it'll blow away the description and it'll set the number back, the number back to 0. So you can't do it before you've looked at, you know, which number you're dealing with, but you can do it here. Okay, so now, so far so good. So now I'm ready to kind of build out my build list function. In fact, maybe I don't want to call it build list. I'm going to call it I'm going to call it add to list. Add to list, because it's not going to build the whole list. It's just going to add one item to the list. So let's go ahead and build it out. I'm going to need a couple of pieces of information here. I'm going to need to know the list name. So list underscore name as a string, list underscore name as string, and list underscore value also as a string. Maybe I'll make this one as variant. I'm not sure it would make the difference one way or the other, but I'd like to be able to, maybe I'm trying to make a list of numbers. I'd like to be able to use a number value to go into it. All right, now what change happens in my environment as soon as I put the arguments or the parameters inside these parentheses? I can no longer do what? Yeah, I can't just run this immediately, because now I'm saying, hey, anytime this runs, you got to give me two values. You got to give me a list name and a value to add to that list. So we go ahead and make my Acme subrunner here. SUB-ACME subrunner. And now, so this will be what I run to test. So I'm going to call list, and I'm going to pass it two values. And I'll just pass it the two values that I would pass it if I was doing, what is it, products, department. So it's department and hunting. It's these two values that I'm going to be giving it. So department and hunting. So now when I run my Acme subrunner, it will just call add to list, and it will pass it the department as department and hunting as the value to add to the list. And so now I've written what I need to write to be able to make sure the sheet is in place. Let's look at a couple other examples of writing an error trap by figuring out what we're going to do. So the idea here is that my list sheet now, I want to put somewhere up here department, and then right below it I want to put hunting, and then later on when I come across general, I want to put general, and then later I want to put outdoor. But I just want what I want my code to do. And if I'm making my list of manufacturers, I want to have a manufacturers list here, and I want manufacturers. So what I have to do is I have to figure out both the column, which is the list, and then the row, which is the place where I want to put the data. And then once I've got that, I know exactly where to write the value onto my list sheet. You see what we're doing here? Having some way that if I send department hunting and then I send department hunting again, it goes, yeah, that's already there. I don't have to worry about it. Department hunting again, yeah, I don't have to worry about it. Department outdoor, oh, I got to add this one to the list. That's what we're trying to build. Okay, so next what I'm going to do is I'm going to figure out which column I have to write to. So let me declare a variable to keep track of that. So dim call as an integer. There's like 16,000 columns, integer plus or minus 32,000, so integer would be just fine for this. And now what I'd like to do, how am I going to figure out which column to write to? Is there any rule that I can follow to know which column that I should write to? How do I know where to write? Which column? Turns out I know the answer to this because I just did this in the last class, but how would you do it? So I know what my list name is, and so if that list name is right here on the first row, it's the column wherever the list name is. If the list name is not in the first row, then it probably should just be my first open column. I'll just write it in the next column over, and I'll start making a new list right here. So there's several ways that we could look to see if it's here. One is that we could just make a loop that loops across and reads them. But it turns out Excel is really good at searching for data. And so if we could just use when I hit over here and press Control F, if I could just invoke this functionality through VBA, that would be great. And we could record ourselves doing it, but we're short on time, so I'll just show you the code that it will generate. So here's what I'm going to do. I'm going to say column is equal to my worksheet S dot, I'm going to look at row number 1. So row is 1, my first row, dot find. So find is what I'm looking for, which is my list name. And the truth is I can't remember these next arguments. But the third one is, am I looking for a whole match or a partial match? And to tell it whole, I say XL whole. WHOLE. This next one is like, do I start searching after the active cell? Or maybe it's a cell that I start searching after. And this one is like, do I match the case or whatever? And there's a few more that I could put over here as well. But if I've got that list name, 3 commas, and then XL whole, that's going to do me a whole cell match for the value that I'm looking for. Now, this will evaluate to a range. The find method returns a range. I don't want a range. What do I want? I want the column number. Fortunately, there's a property called column. And so if it finds this, in fact, let's just rows. I'm just going to take this up to my immediate window and execute that. And that tells me that happens in column number 2. Column number 2. Rows 1, find. I think, oh, list name. Oh, what's in list name right now? It's blank. My code's not running. And so it's looking for a blank column. That's why it finds it. It doesn't find it in row A or column A. So it finds it in column B. But if I was looking for here department, it would find it in column A. So we're on column number 1. So that's pretty good. But what happens if it's something, I'm looking for something it doesn't find? What will this evaluate to if there's no department? I don't know, but it's not going to be a range. And so there's very little likelihood that dot column is going to mean anything to it. Let me just run that and see what happens. Runtime error. Variable is not set. So there's no, this isn't evaluating to anything. So here's what I'm going to do. I am going to set up an error trap to know if it found it or not. Well, by the way, is there another way that I could check without setting up an error trap for this? Yeah, and it would be better. But I'm trying to teach you guys how to do an error trap. So we're letting the error happen, and we're going to trap it and then behave accordingly. In fact, this is so similar to the structure I had before. I'm just going to copy this on error resume next right down to my goto 0. That structure looks pretty good. And I'll paste this in and tab that in. So I'm going to bring my suspect line and put it after my on error resume next. So here I'm saying, hey, if there's an error, just keep on moving. Oh, all of a sudden, something popped in my mind that I didn't do in my last one, and that is right here, when I delete the worksheet, what is that going to do that's undesirable in my code? It's going to put up that error message that says, are you sure you want to delete the sheet? Well, yes, I'm really sure. So I'll say application dot display alerts equals false. Okay, sorry for that little detour. So I'll leave that up for you to look at. Okay, so now I'm going to try to get here, and that was error number 91, if I'm not mistaken. So if there's no error, that's fine. Else, if the error number is 91. Then here we're going to say column or list, list does not exist. So we'll leave on error go to 0. So if I have an error in the code I'm using to remediate the error, I'll still know about it. And what do I want to do? What do I want to do if department doesn't already show on that sheet and I'm trying to add to the department list? I just want to find the next available slot and put the word department there and go, that's my column. So I'm not going to be deleting anything here. I'm going to say, great, my column now is going to be equal to cells, and I'm going to look at the first row, so row number 1, column number, and I just want to go all the way to the very right. What column number is this? It's XFD. That's the column. It's some big thing. But I mean, I could ask what it is. Active TIVE, active cell.column. It's 16,384. But another way to say 16,384 is columns.count. Now, how many columns are there? And so I'm just going to put columns.count in here. So my column is going to equal, I'm going to send my cell all the way to the far right-hand side. And from there, I'm going to say dot end XL to left. So just as if I went all the way to the end and hit Control left arrow. Now, what is that going to bump into? What, if I did that, if I hit Control left arrow here, what cell would it be on? It'd be the first one that has the data. I'm looking for the first one that doesn't have the data. And so I'm just going to say, well, I want the column that I found, but then I want to add one to it. So if it finds one, I'm going to change it to 2. So that's going to give me the column where I want to write the data, and then I'm ready to write the data to it. In fact, this should be S dot, make sure I'm on the right worksheet we're talking about. And I'll say S dot cells, row number 1, column number call, the one I just figured out, dot value, oops, is equal to my list name. Whatever got passed in as my list name. And then that should be it. We've turned off the error handler, and now we will say a little comment for ourselves. Now I know the column I need to write to. The column to which I need to write. So we're trying to set the column. If it gives us an error, we're going to notice, aha, that's error number 91. I was expecting that. I'll know what to do in that case. Questions? Okay, our only last piece to figure out is what row are we going to write to? Now, we could do exactly the same thing again, but we've already seen the error trap twice. So instead, let me show you how to avoid the error when you're doing a search right here. So in this case, I'm going to say, let me dim found cell as a range. Now I'm going to set found cell equal to S dot, now where do I want to search? I got this whole worksheet. It could have several different lists on it. Which column do I want to search in? To know, because I only want to write this value if it doesn't already exist in the list. So whichever column I just identified is my column, the column I'm working on. So S dot cells, actually found cell equals, let's do it this way, S dot columns, and I'm looking in column number call. Dot find, and now I'm looking for the value, so list value and XL whole. Now, if this succeeds, I am going to bind found cell onto a range. It's going to be a range. If it doesn't succeed, it's going to be bound onto nothing. Oddly enough, in VBA, nothing is something. There's actually an object called nothing. It's the only object that has neither methods nor properties. It's just an object. And it is what all object variables are bound to until they get bound onto something else. And so this will return nothing. So I can actually, there's a couple ways I could do this. Let's do it this way. I'm going to say if found cell is nothing, then we'll do something. So if found cell is nothing, it means that it didn't find it. Otherwise, found cell would be bound onto some other object, some range object. So did not find the value in the column. So now, so at this point, we know we've got to figure out which row to write it to. And so I'm going to say, in fact, I can do this even without defining a row variable. So just the last thing to drop in. So I'm going to do this. I'm going to say s.cells, row number rows.count, very last row, column number call. So I'm going to the column I'm searching in, the very bottom. I'm just going to come up until I bump into something. Column number call dot end XL up. Dot offset 1 row, 0 columns, dot value equals my list value. Whew. This gets me to the right worksheet. I'm looking at a particular cell. Which one? The very bottom row, whichever column I'm currently looking at. From there, I'll do a control up arrow. That will get me to the cell that actually has the value in it. I want to come down 1 cell from that, so I'll offset 1 row, 0 columns. This refers to a range. I want to change the value of that range, and it will be whatever value got passed in here. Oh boy. So I think my code is looking for hunting. So let me take hunting off of my list. I'll leave general and outdoor up there. And I'll run my test data again. And if everything goes well, hunting will show up there in row number 4. If it doesn't go well, we'll have an error. But that's part of the class anyway, is debugging, is tracking down errors. So I can't go wrong with this one. It'll be great. It'll either work or I'll have an error and we can learn how to track it down. So let me just go ahead and run my subrunner here. Ah, it put hunting right in there. Now, here's one thing we can do in debugging. I suppose it didn't quite work right. Well, what I'll do here is instead of just running it, I will step into it. So I'll come up here and I will say debug, step into. If I just hit F8, that will do the same thing. So now this is going to go 1 line at a time. I'll just press F8. And now I've executed that line. Have I executed this line yet? No. It's stopped on the line that it's getting ready to execute. And now F8 will actually it's called step into because it's going to step into this sub-procedure. It's called add to list. I'm going to step into add to list. So F8 will take me right in here, and it will take me through 1 line at a time. Did you see it skip the dim S? I should have pointed that out. Skipped right past that one. Why? It's because memory declarations aren't executable. Those all get processed before the sub-procedure actually starts to run. The interpreter looks at it, what's all the memory we're going to need? It allocates that memory before it starts. So you can't actually stop on those lines because they're not executing. But I'll just keep pressing F8, and I can watch this go through the order that it goes in. Wow, we came in here, so error number must be 1004. And we can go 1 step at a time. Now, it might be very helpful for me. Let me go ahead and stop this, and I'll run it again. But now, let's do this. I want to be able to see what some of these different variables are. Well, I've got some debugging tools that are just built for that. So I'm going to come here to my View menu, and I'm going to view this thing called the Locals window. The Locals window just shows me the value of my variables all the time. Now, I'm not running any code right now, so none of my variables have any values. So there's nothing right now. But as soon as I start running, if there's variables declared in the procedure I'm running, they're going to have values, even if I haven't gotten to them yet. Because remember, all those variables get allocated before the code starts running, and every variable has a default value. So it's going to start off with its default value. So I'll come back up here to my subrunner, and I'll press F8 to get it going. And now I can see, here I am in module 1. There are no variables in this one, but I'll step F8 and step into it. And as soon as I get into this one, we'll see that all the variables now become available. Here, let me zoom in so we can see that a little bit better. Windows plus. So I've got now list name, list value. Yep, those are my 2 parameters. And I can see the values that they have because the value of that is hunting and nothing. Department and hunting. Right now, my variable S is nothing because it hasn't been bound on anything yet. But we're about to change that. So we'll hit F8. I think we'll hit F8. F8. Now I haven't run this one yet, but watch what happens when I run this. this is going to change from nothing to what it's bound onto. And so now S has a little plus by it. Welcome to Outlook. That's neat. Cancel. Yes, I want to exit that wizard. So I kind of expected, I wonder why that's trying to email me. That's so interesting. There, it's open now. Why that was emailing? Thank you, Microsoft. I don't know. So S is a worksheet, and worksheets have lots of properties. It's got the cells property. Should have a name property down here if we can get to it. Here is the name property, and sure enough, it's sheet 6. That's the name property. So the locals window just shows you all of the values of your variables, and if those are object variables, it'll show you all the properties of those objects. And I can collapse that one down because I really don't want to see that, so deeply. Column hasn't been set yet, so let me just kind of F8 until column gets set. So working on the worksheet. Okay, so here I'm about to set the column. So I'll press F8 and we should see that column go from 0 to something different. Yeah, so it found it in column 1, and I can see the values change as I go step by step. So the locals window is really helpful in finding out what your code is doing because you can actually see in the memory what values they have. Locals window is great, but the locals window only takes us so far because it only shows us like bare values. So what if I want to see something that's more complex? Or I don't want to have to look into the whole error object to see the number. I just want to see the number itself. So for that, I'll do this. So let me go ahead and I'm going to highlight this whole expression. So error number, I'm going to right click it and I'm going to choose add watch. So a watch expression allows me to see the value of something that's more complex than just a single variable. So I don't want to see the whole error object. I don't have to open it up and look at it. Instead, I just want to see what that number is. I'll say OK. And that will bring up another window similar to my locals window, but now this one has the more complex expressions in it. And so right now, the value of the error is 0. And so we should be able to kind of continue going through to see when it changes. So F8 and F8. We're stepping through. And I don't think we're going to see that error change. But if that error was to change, we would see it change. In fact, I'm going to go ahead and kind of run this again, just F8 to step through it. And I think we'll see the error when we try to create. When we try to name the list here, we should see that error number change. Yeah, there it is, now 1004. Okay, so I can see that. Now, sometimes what you're saying is, hey, I don't just want to see that value. I don't want to have to step through it. I know that somehow I'm getting error number 1004, but I'm not sure where it's happening. And so there's a really slick thing that we can do here. And I'm going to highlight this expression and right click, and I'm going to choose add watch. But now, instead of just adding a normal watch expression, I'm going to say break when the value is true. So my expression is now going to be error number equals 1004. And I want this to take me into break mode when this condition becomes true. So I don't know where it might happen or what might cause it to happen, but if it does, stop executing the code and show me the line that's the next executable line. It won't show me the line that caused it to happen, but it will show me the next line after it. Ah, this is really great. So now I may not know where this error is happening, and you would use this not so much for runtime errors, because runtime errors you can track down pretty easily. But let's say you've got a variable, like a variable x, that's getting to be 100, and you're not sure when it's getting to be 100, but that's a problem. Windows minus. You can say, hey, when this error becomes this value, just go ahead and stop. So let me stop my code here, and I'll run my code again. And now it's taking me into break mode. And it even tells me over here, this is the thing that caused me to do it. It's highlighted this in blue. And is this the line that made the error happen? No, it's the next line after. This is the line that made the error happen. But it stops me on the very next executable line, so I can go, oh, that's the line that caused the problem. That is called a conditional breakpoint. So you might want to know what a non-conditional breakpoint is. Let's talk about those. It's a really important thing as well. So we've seen one way that we can stop our code is with, and we've used this several times this semester, this is the keyword stop. You know, when we get to the words, when we get to stop, it just takes us into break mode. Let me go ahead and run this. And boom, I'm in break mode right there. I can kind of snoop around. I can print off the values of my variables. You know, what is s.name? S.name is not yet defined, so that's great. I can look in my immediate window and see things. So that is a breakpoint written in code. But I can also put a breakpoint that I just click on the gray bar next to my text, and it will put a red line onto that line. Now, chances are that by now, most of you have done that accidentally. And you went, oh my gosh, what I've done, there's a red line. And what did you do? You were still holding your breath. You clicked it again, it went away, and you went, ah, whew. But that's a great thing in debugging, because now we don't have to put the word stop in there. It'll just stop when it gets to that line. So that's a regular old breakpoint, or using the watch window, we can make a conditional breakpoint that takes us into break mode once some condition becomes true. And so now I'm going to go ahead and stop this. And instead of pressing play, pressing F8 to run it, I'm just going to press play. And it will run right up to that breakpoint. And then it's stopping on that breakpoint. I could start stepping from here, or I can come look around and kind of snoop around, do my snooping. Okay, a couple more things to talk about, and that is the other options that we have besides step into in terms of stepping. So let's turn off this breakpoint. I'm going to come right back up here. I'm going to press F8 to get started. I'll press F8 again. Now, at this point, I'm about to make a call to another sub-procedure. And so when I am on a line that's a call to another sub-procedure, I have a couple of options. If I just step into, like F8, it will actually go and start going through this one line at a time. Right? That's just doing one step at a time. But I might say, oh, I know the problem is not inside this sub-procedure. Just finish the rest of the sub-procedure. Don't skip the lines, but just finish them and take me back to where this procedure was called from. Well, that is debug called step out, or Control-Shift-8. But if I run this, it will finish off this whole sub-procedure very quickly and come to the next line after the sub-procedure was called. So step out says, hey, I'm in a sub-procedure, finish this one off and take me up back to where it was called from. The third way that we can step is called step over. So let me just drag, and the neat thing is I can drag this line to where I want it to go. So I'll drag it back up here. I'm not sure dragging works in the Mac version to drag the arrow. Does it work? Anyone with Mac? When you're in break mode, can you drag it to another line? I'm just not sure. Didn't used to, maybe it does now. The last one is step over. Now, it's a bit of a misnomer here, because you're going to think, if I'm on this call to a sub-procedure and I step over it, I mean, what if you were walking down the sidewalk and you saw something that you didn't want to step in, and so you stepped over it? What would happen? You're skipping past it altogether. But here, when I say step over, it does not skip the line. It runs the whole sub-procedure without going into it. So I will step over this one. View. In fact, let me go ahead and put my list sheet back on here. I'm going to take hunting off. That's what it's going to try to put back on. And I'm going to step over it. Debug, step over. And it looks like we're creating a sheet that we're not quite deleting. We'll have to go figure that out. But it did. Oh, no, I haven't got there yet. Why didn't I stop? Oh, because I have this conditional breakpoint. So let me continue running here. And you can see that it actually went in there, but it didn't go step by step. It stopped because I had that conditional breakpoint. So those are the three kinds of stepping. Step into just goes one line at a time, regardless of what it is. Step over says, hey, there's a whole sub-procedure here. Run the whole thing. I don't want to step through it. And then step out says, I'm in a sub-procedure. Let me out of here. We've seen add watch. You can edit your watch expressions as well, and clear all the breakpoints that you might have set, and so forth. Okay, we're just about done. But let me see if I can figure out why I've got the problem here that I'm not deleting. Here, go to 0.
Is it that you're kind of entering the code and then you're stopping it before it has a chance to delete the code?
Seems like it's, yeah, so the point is maybe it's because I'm stopping it. That could be what it is. Let me delete these all. Maybe that's just what it is. It's just that I stopped and then didn't run the code from there. So let's delete. And let me just run it again without any breakpoints. Take this, get rid of this one. Delete. And run my code again. Oh yeah, that's what the problem is. But looks like that works okay. Well, the last thing that we don't have time to do is actually integrate this, because one thing I'd like to do is, instead of just calling this with add to list with some variables in here, or hard-coded values, I'd like to come through in here, actually come to my existing process products, which already goes through all these products, and have it build the list. I would just have to put the right parameters to send there, and it would build these lists out. But we're out of time, so I'll leave that as an exercise for the interested student. All right, thanks for coming. Class dismissed.